Now let's talk about preparation of amines. So guys, before beginning with the lecture, please consider subscribing my channel, hit the like button and become a part of our family, and share this videos with your friends and give your feedback in the comment section. I will be eagerly waiting for it. Now let's start with preparation of amines. Amines are prepared by the following methods. Reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, platinum or palladium, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. Nitro compounds are reduced to amines by passing hydrogen gas. So you can convert nitro compounds into amines by reducing nitro compounds to amines by passing hydrogen gas in the presence of finely divided nickel, platinum or palladium, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. So you have to take, like here, let's see the examples. You have to take nitrobenzene in the presence of hydrogen gas and finely divided palladium in the presence of ethanol, and you will get aniline or benzenamine. Aniline is a common name, but it is also accepted by IUPAC, and strictly talking about IUPAC name, so it is benzenamine. Now, in which E of the benzene is replaced by A, so it is called benzenamine. Not the second method is reduction with metals in acidic medium. So nitrobenzene, by reducing it with tin, Sn plus HCl, or iron plus HCl, Fe plus HCl, we get benzenamine or aniline. Reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Reduction with iron scrap is preferred because reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Thus, only a small amount of HCl is required to initiate the reaction. See, how can you prepare amines? By reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, platinum or palladium, and also by reduction with metals in acidic medium. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. Nitrobenzene in the presence of hydrogen, in the presence of by passing hydrogen gas in the presence of finely divided palladium, nickel or platinum, you can use in the presence of ethanol, and you will get aniline or benzenamine. The second method is nitrobenzene by reducing with metals in acidic medium. Metals like tin, Sn plus HCl, or Fe plus HCl, you will get aniline and benzenamine. Reduction with iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Thus, only a small amount of hydrochloric acid is required to initiate the reaction. Now, the second major method is ammonolysis of alkyl halide. So there are two things. One is ammonolysis of alkyl halide, and another is ammonolysis of alcohols. Alcohols part is not given in NCERT, but we'll discuss it because it is important for NEET. Now, ammonolysis of alkyl halides. You have read in Unit 10, Class 12 that the carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. So, it is saying that in Unit 10, Class 12, that the carbon hydrogen bond in alkyl or benzyl halide can be easily cleaved by a nucleophile. So in ammonolysis of alkyl halides, it is saying that in unit 10 class 12 you have read that the carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. So if you have not watched my this chapter 10, that is alkyl and aryl halides, you can go and watch it and complete the chapter. It's very easy. Simply you have to put the earphones in your ears and just you have to listen it, and I have repeated the lines many times that you can just get it by listening. So it's very simple to complete the NCRT with this method, but please share it with your friends. Talking about that, the carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. Hence, an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia. Ethanolic solution of ammonia undergoes nucleophilic substitution reaction in which halogen atom is replaced by an amino NH2 group. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. So here there is a sealed tube at 373 Kelvin. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines, and finally quaternary ammonium salts. So the carbon halogen bond in alkyl or benzyl halide can be easily cleaved by a nucleophile. Carbon halogen bond in alkyl or benzyl halides in both can be easily cleaved by a nucleophile. Hence, an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia undergoes nucleophilic substitution reactions in which the halogen atom is replaced by an amino NH2 group. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. The reaction is carried out in a sealed tube at 373 Kelvin. The reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines, and finally quaternary ammonium salt. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines, and finally quaternary ammonium salts. This reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines, and finally quaternary ammonium salt. So nucleophile NH3 with lone pairs on nitrogen plus Rx. So the bond with Rx is broken, and instead of X, ammonia is substituted, so it is called substituted ammonium salt. Then RNH2 reacts with another Rx to form R2NH, then with another Rx to form R3, and another Rx to form quaternary ammonium salts. So hence an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia undergoes a nucleophilic substitution reaction in which the halogen atom is replaced by an amino NH2 group. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The free amine can be obtained from the ammonium salts by treatment with a strong base. So like RNH3 plus X minus plus NaOH plus charge on nitrogen and minus charge on halogen plus NaOH, it will form RNH2 plus H2O plus NaX. Ammonolysis has the disadvantage of yielding a mixture of primary, secondary and tertiary amines, and also a quaternary ammonium salt. However, primary amine is obtained as a major product by taking large excess of ammonia. The order of reactivity of halides with amines is Ri greater than Rbr greater than Rcl. Because Ri bond is weaker, it will break easily, and I minus will act as a strong nucleophile. Ri is there, okay, and it can be easily substituted. So one thing you have to remember, that carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. Hence, an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia undergoes nucleophilic substitution reaction, in which the halogen atom is replaced by an amino NH2 group. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtained behaves as a nucleophile and can further react with the alkyl halides to form secondary, tertiary, and finally quaternary ammonium salts. So the free amine can be obtained from the ammonium salt by treatment with a strong base. The free amine can be obtained from the ammonium salt by treatment with a strong base. RNH3 plus X minus plus NaOH, RNH2 plus water plus NaX. Ammonolysis has the disadvantage of yielding a mixture of primary, secondary, tertiary, and quaternary ammonium salts. However, primary amine is obtained as a major product by taking large excess of ammonia. If you take large excess of ammonia, then only you can get primary amine. The order of reactivity of halides with amine is Ri greater than Rbr greater than Rcl. Very important thing, example 13.1. Write chemical equations for the following reactions. Reaction of ethanolic ammonia with C2H5Cl. Reaction of ethanolic ammonia with C2H5Cl. What finally will get quaternary ammonium salt. So C2H5Cl reacting with ammonia, it will form C2H5NH2. Primary amine ammonia, one hydrogen is replaced by C2H5 alkyl group. So C2H5 alkyl group attached with NH2. C2H5Cl, again C2H5 taken twice NH, then C2H5Cl, C2H5 taken thrice N, then C2H5Cl, C2H5 taken thrice N plus Cl minus. So chloroethane to ethanamine, then N-ethyl ethanamine, then N, N diethyl ethanamine, then quaternary ammonium salt. See, next thing, ammonolysis of benzyl chloride and reaction of amines so formed with 2 moles of CH3Cl. Benzyl chloride, ammonia, C6H5CH2NH2. So benzyl chloride. So C6H5CH2Cl, benzyl chloride. C6H5CH2Cl is benzyl chloride, NH3. C6H5CH2NH2 is benzyl amine. So benzyl chloride, C6H5CH2Cl, NH3, C6H5CH2, NH2 benzyl amine. Then with 2 moles of CH3Cl, get C6H5CH2, CH3, CH3, N, N dimethyl phenyl methanamine. So ammonolysis of benzyl chloride and reaction of amines so formed with 2 moles of CH3Cl. Benzyl chloride will form benzyl amine. Ammonolysis of benzyl chloride and reaction of amines so formed with 2 moles of CH3Cl. So first, benzyl chloride is reacting with ammonia to form benzyl amine. With 2 CH3Cl, you get N, N dimethyl phenyl methanamine. N, dimethyl phenyl methanamine. Now reduction of nitriles. Nitriles on reduction with lithium aluminium hydride LiAlH4 or catalytic hydrogenation produce primary amines. This reaction is used for ascent of amine series, that is for the preparation of amines containing 1 carbon atom more than the starting amine. One more thing I said, that there is another called ammonolysis of alcohols. Let's discuss it. So when 1 degree alcohols are treated with ammonia in the presence of hot Al2O3 or THO2, that is thoria, at 623 Kelvin, gives a mixture of 1 degree, 2 degree, 3 degree amines. Because see, C2H5OH, OH group from alcohol and H group from NH3. So the water molecule will come out and it will form C2H5NH2 in the presence of hot Al2O3 or thorium oxide, that is thoria, THO2. So you have to take hot Al2O3 and THO2 at 623 Kelvin, then you will get C2H5NH2, then C2H5OH, then again water molecule will come out, it forms C2H5NH2H5, then again C2H5OH will react, then C2H5 take entries and will form. Okay, so this was about ammonolysis of alcohols. And talking about reduction of nitriles, nitrile means RCN, RC triple bond N. So nitriles on reduction with lithium aluminium hydride, that is LiAlH4, or catalytic hydrogenation, produce primary amines. The reaction is used for ascent of amine series, that is for the preparation of amine containing one carbon atom more than the starting amine. RCN in the presence of H2, nickel, lithium aluminum hydride, NaHg, C2H5OH, RCH2 and H2 will form, because C triple bond N will be reduced to CH2 and H2. So RCH2 and H2 will form. So you can produce primary amines. So you can produce primary amines by this. Reduction of nitriles. Talking about reduction of nitriles, nitriles on reduction with lithium aluminium hydride, LiAlH4, or catalytic hydrogenation, produce primary amines. This reaction is used for ascent of amine series, that is for preparation of amines containing one carbon atom more than the starting amine. So ascent of amine series means that is for the preparation of amines containing one carbon atom more than the starting amine. So if you want to produce amine with one carbon atom more than the starting amine, that is RCN, RC triple bond N, in the presence of lithium aluminium hydride, or catalytic hydrogenation, or in the presence of sodium, or in the presence of sodium and ethyl alcohol, or sodium amalgam, NaHg ethyl alcohol, you will get RCH2 and H2. Reduction of amides. Amides on reduction with lithium aluminium hydride yield amines. What are amides? Amides are derivatives of carboxylic acids, that is RC double bond O NH2. RC double bond O NH2 is called amide. By reducing in the presence of lithium aluminium hydride, you will get RCH2 and H2, RCH2 and H2, RCH2 and H2, RCH2 and H2. You will get RCH2 and H2. That is reduction of amide. So lithium aluminium hydride can reduce amides into amines. So what lithium aluminium hydride does, it takes out hydrogen from itself and gives to amide. So C double bond becomes CH2 and NH2 is there. So RCH2 and H2. Reduction of nitriles. RC triple bond N H2, nickel lithium aluminium hydride, NaHg, C2H5OH, RCH2 and H2. Let's talk about Gabriel thalamide synthesis. Gabriel synthesis is used for the preparation of primary amines. What is Gabriel thalamide synthesis? So today we will complete up to preparation of amines and physical properties of amines. Then tomorrow we will do chemical reactions of amines. There is so much in chemical reactions. There is so much in chemical reaction. There are so many reagents and many things. Electrophilic substitution reactions are there. Then later we will do diazonium salts, method of preparation of diazonium salts. Okay. And if you have not watched my carboxylic acids NCRT, listenable or audible NCRT, you can go and go through that video. It's very interesting. Each and everything you will remember after watching that. So let's talk about fifth one, Gabriel thalamide synthesis. So Gabriel thalamide is used for the preparation of primary amines. So you can prepare primary amines by Gabriel thalamide synthesis, and by reduction of nitriles also you can get primary amines. And Gabriel thalamide synthesis also for the preparation of primary amines. Thalamide on treatment with ethanolic potassium hydroxide forms potassium salt of thalamide, which on heating with alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. Aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by thalamide. So Gabriel thalamide synthesis. Gabriel thalamide follows SN2 mechanism. It is for the preparation of primary amines first of all. So SN2 mechanism and primary amines. Gabriel synthesis is used for the preparation of primary amines. Thalamide on treatment with ethanolic potassium hydroxide. Ethanolic potassium hydroxide forms potassium salt of thalamide. So you have to take thalamide. What is thalamide? Benzene ring, C double bond O, NH, C double bond O. So C double bond O, NH, C double bond O is thalamide. So benzene, C double bond O, C double bond O, NH is thalamide. On treatment with ethanolic potassium hydroxide, thalamide is already having NH group and 2 C double bond O group, 1 benzene group. So benzene, C double bond O, C double bond O, NH. By treating with ethanolic potassium hydroxide, KOH, it will form potassium salts of thalamide. Instead of hydrogen K plus will be there. So N minus K plus, which on heating with alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. So potassium salt of thalamide is which on heating with alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. So you have to take thalamide. Thalamide is benzene, C double bond O, C double bond O, NH. In the presence of KOH, ethanolic potassium hydroxide, then you get potassium salt of thalamide. Potassium salt of thalamide on heating with alkyl halide, that is RX. On heating with alkyl halide followed by alkaline hydrolysis. So what will happen after treating with potassium hydroxide? Ethanolic potassium hydroxide will form potassium salt of thalamide. Instead of hydrogen, N minus K plus is there. Potassium salt of thalamide, which on heating with alkyl halide, what it will give? An alkyl thalamide. The K plus is substituted by R plus, because in RX R plus X minus, so K plus is substituted by R plus on heating with alkyl halide. So potassium salt of thalamide on heating with RX gives an alkyl thalamide. So an alkyl thalamide on alkaline hydrolysis means hydrolysis in the presence of NaOH base alkali. So it will give you corresponding primary amines, and that benzene, C double bond O, O minus Na plus, O minus Na plus, NH is given to the 2 hydrogens are given to RNH2 will form. That is primary amine. See, aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by thalamide. So aromatic primary amines cannot be prepared by this method. Because aromatic primary Aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by phthalimide. So aromatic primary amines cannot be prepared by this method. Aromatic primary amines cannot be prepared by this method. Aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with the anion formed by phthalimide. Because aryl halides do not undergo nucleophilic substitution with the anion formed by the phthalimide. Because aryl halides do not undergo nucleophilic substitution with the anion formed by the phthalimide. With the anion formed by the phthalimide, aryl halides do not undergo nucleophilic substitution with the anion formed by the phthalimide. With the anion formed by the phthalimide, aryl halides do not undergo nucleophilic substitution. So aromatic primary amines cannot be prepared by this Gabriel phthalimide synthesis because aryl halides do not undergo nucleophilic substitution with anion formed by the phthalimide. So what do you have to take? Phthalimide. What is phthalimide? Benzene, C double bond O, C double bond O, NH. And taking ethanolic potassium hydroxide. So we'll get benzene, C double bond O, C double bond O, N minus K plus. Then RX, heating with alkyl halide, we will get N alkyl phthalimide. N alkyl phthalimide, benzene ring, C double bond O, C double bond O, NR. Then this on alkaline hydrolysis, NaOH aqueous hydrolysis will give benzene. This is called alkaline hydrolysis in presence of strong alkali like NaOH. Benzene, C double bond O, O minus Na plus, C double bond O, O minus Na plus plus RNH2. So primary amine is formed by using this phthalimide. Hofmann bromamide degradation reaction. Hofmann bromamide degradation reaction, that is HBD reaction. So Hofmann bromamide degradation. So Hofmann developed a method for preparation of primary amines by treating an amide with bromine. Hofmann developed a method for the preparation of primary amines by treating an amide with bromine. By treating an amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon to the amide, carbonyl carbon of the amide to the nitrogen atom. Carbonyl carbon of the amide to the nitrogen atom. The amine so formed contains one carbon less than the present in the amide. See, Hofmann bromamide degradation is nothing but HBD reaction. In this also we are preparing primary amines, same as Gabriel phthalimide and reduction of nitriles. Hofmann developed a method for the preparation of primary amines by treating an amide with bromine in the presence of aqueous or ethanolic sodium hydroxide. So in this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. The amines so formed contains one carbon less than that present in the amide. So the amine so formed contains one carbon less than the present in the amide. So here we are getting one carbon less. See, RC double bond O NH2. This is amide with bromine Br2 plus aqueous or ethanolic sodium hydroxide for NaOH. Since we are using ethanolic, in Gabriel phthalimide, ethanolic potassium hydroxide. In Hofmann bromamide degradation, ethanolic or aqueous sodium hydroxide. So we'll get RNH2 because in this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. So the amine formed contains one carbon less than the then that present in the amide. Like amide is having 2 carbon atoms, then amine will be having 1 carbon atom. That is 1 carbon less than the amide. RNH2 plus Na2CO3 plus 2 NaBr plus 2 water. Na2CO3 plus 2 NaBr plus 2 water. So Hoffman developed a method for the preparation of primary amines by treating an amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. The amine so formed contains 1 carbon less than that present in the amide. Acid double bond NH2 plus Br2 plus NaOH. RNH2 plus Na2CO3 plus 2 NaBr plus 2 water molecules. Write chemical equations for the following conversions. CH3 CH2 Cl into CH3 CH2 CH2 NH2. So how can you do this? See, one more thing, in HBD reaction you are getting 1 carbon less, but in reduction of nitriles you are getting 1 carbon more than the nitrile. So these are like opposite type. But in nitriles we are using catalytic hydrogenation or lithium aluminum hydride or the sodium amalgam ethanol or sodium ethanol. Now, how can you prepare ethyl chloride to propanamine? So you have to use reduction of nitriles one. So first you take chloroethane and treat with ethanolic NaCN. So you will get CH3 CH2 C triple bond N. It's called propane nitrile. Ethanolic NaCN you have to take. So the CN group will be replacing the Cl. So CH3 CH2 CN will form. It's called propane nitrile. On reduction with lithium aluminum hydride or catalytic reduction and sodium amalgam C2H5 or sodium C2H5, you will get propane 1 amine or propanamine. CH3 CH2 CH2 NH2. Now how can you prepare benzyl chloride into C6H5 CH2 CH2 NH2, that is 2-phenyl ethanamine. How can you prepare? So for that take chlorophenyl methane, means benzyl chloride treated with ethanolic NaCN. So you will get C6H5 CH2 C triple bond N, phenyl ethane nitrile benzyl cyanide, phenyl ethane nitrile you will get, that is benzyl cyanide, and 2-phenyl ethanamine will be obtained. So 1 carbon if you want more, then you have to take nitrile. Like here I was wanting to prepare propane 1 amine, propanamine from ethyl chloride. So I have treated ethyl chloride with ethanolic NaCN and I got propane nitrile CH3 CH2 C triple bond N. And this propane nitrile on reduction with lithium aluminum hydride or with catalytic hydrogenation, like in the presence of hydrogen and nickel, and sodium amalgam in the presence of ethyl alcohol. So we'll get propan 1 amine, propanamine, and you can also treat with how can you prepare C6H5 CH2Cl, that is called benzyl chloride, chlorophenyl methane, ethanolic NaCN, treating with ethanolic NaCN, then it will form C6H5 CH2 C triple bond N, phenyl ethane nitrile benzyl chloride, phenyl ethane nitrile benzyl cyanide, and hydrogen nickel catalyst will get 2-phenyl ethanamine C2H. Okay, so this is the thing. So you will get write structures and IUPAC names of the amide which gives propanamine by Hoffman bromide reaction. So the amide you have to know. So one carbon less you will get. So it means you have to take butamide. Like you have to take 4 carbon amide called butanamide. That is called butanamide. The amine produced by that is CH3, CH2, CH2, C double bond O, NH2. So this CH3, CH2, CH2 is transferred to NH2 by degradation reaction, and this actually takes place in the presence of ethanolic or aqueous NaOH and Br2. So HBD, Hoffman bromide degradation. It will also form primary. Gabriel thalamide also primary. Reduction of nitriles also primary. Okay, so you are getting primary amines. Propanamine contains 3 carbons. Propanamine contains 3 carbons. So how many carbons propanamine contains? Propanamine contains 3 carbons. See, propanamine contains 3 carbons. So propanamine contains 3 carbons. Hence, the amide molecule must contain 4 carbon atoms. Okay, this is done. Structure and IUPAC name of the starting amide with 4 carbon atoms are given. Okay, the amine produced by Hoffman degradation of benzamide. Benzamide means aniline. So the amine produced by Hoffman degradation of benzamide you have to take. It's benzene, C double bond O, and H2. So benzamide is an aromatic amide containing 7 carbon atoms. 7 carbon atoms are present in benzamide. Hence the amine formed from benzamide is aromatic primary amine containing 6 carbon atoms. Benzamide is an aromatic amide containing 7 carbon atoms. Hence the amine formed by the benzamide is aromatic primary amine containing 6 carbon atoms. So what is benzamide is C6H5 CH2 NH2 is called benzamide. C6H5 C double bond O NH2. Okay, so it will form aniline or benzenamine. How will you convert benzene into aniline? So you can take nitrobenzene. How can you do? You can take nitrobenzene. And you can do its catalytic hydrogenation in the presence of by passing hydrogen gas in the presence of finely divided palladium, platinum or nickel. Or you can also use metal in the presence of acid like SnHCl or FeHCl. Iron scarb and hydrochloric acid is preferred more because the FeCl2 being prepared is hydrolyzed to hydrochloric acid. So less amount of hydrochloric acid is required to initiate the reaction. Less amount of so there's a small amount of hydrochloric acid is required to initiate the reaction. And like this you can prepare benzene to aniline. So benzene you have to first do its nitration. Then you will get nitrobenzene and then you can convert it into aniline. Okay, then you can convert it to aniline. Benzene into N, N dimethyl aniline. Cl CH2 taken 4 Cl into hexane 1,6 diamine. You can do this. Now physical properties. The lower aliphatic amines are gases with fishy odor. So fishy odor, lower aliphatic amines are there, no straight chain. They have fishy fishy odor and they are gases. They are gases, they are having fishy odor. Primary amines with 3 or more carbon atoms are liquid and still higher ones are solid. Up to 3 like primary amines with 3 or more carbons, they are liquid. More carbon atoms, they are liquid and still higher ones are solid. Aniline and other aryl amines are usually colorless. Aniline and other aryl amines are usually they are colorless but get colored on storage due to atmospheric oxidation. They get colored. So suppose I took aniline in a test tube. It was colorless, and I took some other aryl amine. It was colorless, but after some time I found that it became colored. How? Because on storage due to atmospheric oxidation. Lower aliphatic amines are soluble in water. See, lower aliphatic amines, they are soluble in water because they can form hydrogen bonds with water molecule. Because they can form hydrogen bonds, so they are soluble. What? Low aliphatic amines. However, solubility decreases with increase in molar mass of amines due to increase in the size of the hydrophobic alkyl part. The solubility decreases. Higher amines are essentially insoluble in water because more hydrophobic part. Considering the electronegativity of nitrogen of amine and oxygen of alcohol, electronegativity of nitrogen of amine and oxygen of alcohol as 3 and 3.5 respectively, nitrogen 3 and oxygen 3.5. You can predict the pattern of solubility of amines and alcohol in water. Out of butane 1-ol and butane 1-amine, which will be more soluble in water and why? Butane 1-ol and butane 1-amine. Amines are soluble in organic solvents like alcohol, ether and benzene. These are soluble in organic solvents, alcohol, ether, benzene. You may remember that alcohols are more polar than amines and form stronger intermolecular hydrogen bonds than amine. So they are more soluble. So that's why in between butane 1-ol and butane 1-amine, butane 1-ol is more soluble in water than butane 1-amine because butane 1-ol is having alcohol that is more polar than amines and forms stronger intermolecular hydrogen bonds than amines. So alcohols are more polar than amines and form stronger intermolecular hydrogen bonds with amines. Primary and secondary amines are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. So primary and secondary amines are engaged in intermolecular association. Primary and secondary amines are engaged in intermolecular association due to hydrogen bonding. So primary secondary amines, they can form intermolecular hydrogen bonding. So their associations are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. So primary and secondary amines are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. This intermolecular association is more in primary amines than in secondary amines, as there are 2 hydrogen atoms available for hydrogen bond formation in it. So in primary amines there are 2 hydrogen atoms available for hydrogen bonding, whereas in secondary only 1 hydrogen atom is available. So this intermolecular association is more in primary amines than in secondary amines, as there are 2 hydrogen atoms available for hydrogen bond formation in it. Tertiary amines do not have intermolecular association due to the absence of hydrogen atom available for hydrogen bond formation. So tertiary amines do not have intermolecular association due to the absence of hydrogen atom available for hydrogen bond formation. So no hydrogen bonding, no intermolecular hydrogen bonding. Therefore the order of boiling points of isomeric amines is as follows. Primary amine is having more boiling point than secondary than tertiary. Intermolecular hydrogen bonding in primary amines is shown. So both hydrogens are involved in intermolecular hydrogen bonding. Boiling points of amines, alcohols and alkenes of almost of the same molar mass are shown. Comparison of boiling points of amines, alcohols and alkanes. Hmm, alcohols, amines, alcohols, alkanes, almost same molar mass are compared with similar molecular mass. C compound N butanamine, so it is having 73 molar mass, 350.8. Whereas if you see dimethyl, 73 molar mass, diethylamine, N diethylamine, or you can say N ethyl ethanamine, or you can say diethylamine. It is having molar mass 23, its boiling point 329.3. Whereas C2H5N CSC taken twice, tertiary amine, it is having 310.5, and C2H5CH CSC taken twice, this is nothing but alkane, it is having 72 molar mass and 300.8 boiling point, very less. And C4H4H9OH 74 molar mass and 390.3, so it is having highest boiling point. So alcohols are having more boiling points than amines. Alcohols more boiling point than amines. Alcohols having more boiling points than amines. This is called boiling point order. Chemical reactions we discuss is another class. See, basic nature of amines is directly proportional to K. K basic, inversely proportional to pKb, directly proportional to pH, directly proportional to P character, inversely proportional to S character, directly proportional to plus I effect, inversely proportional to minus I effect, inversely proportional to oxidation number, inversely proportional to electronegativity. See, order of basicity of amine: secondary greater than primary, tertiary, ammonia, C6H5NH2. This is basicity of amines, so we'll discuss it in next video. So we have done with physical properties, and tomorrow we'll do chemical properties.